Okay, so today we're going to talk about chemical bonds. In particular, we're going to talk about ionic bonds. Keep in mind, there are three types of chemical bonds that we're going to talk about. Ionic bonds, which are nonmetals, bonded to metals. And then we have covalent bonds, which are metals. I'm sorry, are nonmetals to nonmetals. To nonmetals. And metallic bonds are metals to metals. And we'll talk about more about the covalent bonds next time and metallic bonds in the next couple of lessons. But right now we're going to talk about the ionic bonds. Okay, there are a couple of terms that you need to know. First off, an anion and a cation. And keeping these straight is not always easy, except it tells you in the name what it is. A cation, C, a positive ion. So a cation is a positive ion. An anion is a negative ion. And remember, an ion is a atom that has a charge. So an ion is an atom that has gained or lost an electron. So an anion has a negative charge, so it has gained an electron. Electrons are negative, so that means we have more negativity. A cation is a positive ion. It has lost a negative, so it is now positive. Okay, so back to, and we lose and gain electrons into the valence shell. And so remember, we can predict how an atom is going to behave based on how many valence electrons it has. So hydrogen has one valence electron. So it has one valence electron. And so these are the Lewis dot structures. The Lewis dot structures only show valence electrons. So magnesium has two electrons. And it does not matter how you put these on. Lithium has, remember we had group 1 all has 1, group 2 has 2, group 13 has 3, group 14 has 4, 15 has 5, 6, 7, and 8. And so remember, our noble gases have a full dinner table. Nobody can come sit and join them, and nobody can leave. They have a full dinner table. They are happy. So lithium, where was lithium? Lithium also has two electrons. Or one, I'm sorry, it's in group 1, so it has one valence electron. So it has a similar reactivity as hydrogen or sodium, because everything in that one group has one valence electron, so it has similar reactivity. Aluminum is in group 13 or 3A, so it has 3. 1, 2, 3. Germanium has 4. And fluoride has 7, or fluorine, 2, 3, 4, 5, 6, 7. Okay, so that's how to write the Lewis dot formula. An anion is a negative, a cation is a positive, Ca positive ion. Okay, so let's talk about if lithium and fluorine. We had lithium and fluorine. Lithium has one valence electron. Fluorine has 7. Well, is it easier for lithium to give 1 or pick up 7? And it's easier for them to give up 1. It takes less energy to give up 1 than to move 7 the other way. So the lithium is going to lose 1 and go here. So we have now lithium has lost a negative, so lithium positive, and fluorine has gained it, so it is negative. So the way to write this formula, well, first of all, the name, lithium, we always write our nonmetal first. The nonmetal gets written first. And then the metal. And I said that completely backwards, which means I wrote it down backwards. We have our metal and our nonmetal. So we have lithium, and then we have fluorine. But when we write these chemical names, we're going to change the INE to IDE. So it should be lithium fluoride. Now to write the chemical formula, we said that lithium had a +1 charge. We said that fluorine had a -1 charge. You're going to take your charges minus the signs and crisscross them. So we're going to have lithium, oh, lithium 1 fluoride. Just like in math, ones are understood, so lithium fluoride. So let's do lithium oxide. Lithium and oxygen. The dot structure, oxygen is in group 16, so it has 6 valence electrons. And lithium still has just 1. So lithium can donate its 1, but it still needs another one. There's still an open space at the table. So another lithium will donate 1. So lithium oxide, and that is how you write the uh, Lewis dot structures and indicate what's going on for lithium oxide. And I'm using the pink and the blue because I have that option. If I'm using just pencil or a pen or at the whiteboard or whatever, I sometimes use circles and X's so I can see where my electrons are coming from and going to. So again, that's lithium oxide. So the formula, we said lithium has a +1 charge. We said oxygen, because it's in group 16, has a -2 charge because it's picking up 2 electrons. You take the number, crisscross it, and drop the charge. So lithium 2 oxide. So let's look at calcium sulfide. And I'm going to bring this down so I can see it. if you wanted to write your charges, we talked about the number of valence electrons. The other thing you can talk about is what are the charges on it. So on group 1, they're going to lose 1 electron, so it is plus 1. Group 2 is going to lose 2 electrons, so it is plus 2. Group 13 or 3A is going to have 3 electrons that it's going to lose. Group 4, if it is a nonmetal, it will gain electrons. If it's a metal, it will lose electrons. So it can be plus or minus 4, depending. There's lots of weird rules with group 4. The next group will gain 3. It's easier to gain 3. It's going to take less energy to gain 3 than to lose 5. So it's going to gain 3. So it's going to gain 3 negative. So it's negative 3. Group 16 or 6A is going to gain 2. So 2A. And group 17 will gain 1. And this group is stable and happy. So calcium sulfide. Calcium is in group 2. We said it has a plus 2. Sulfur is in group 16. So it has a negative 2. So Ca2S2, in ionic compounds, you always reduce it all the way down. So this would be calcium sulfate or sulfide. Its Lewis dot structure. Calcium had 2. Sulfur had 6. So these two would go here and there. Okay, so now talking about our transition elements. Talking about our teenagers are down here. I cannot predict how they're going to behave. I have to know something about them. Did they get enough sleep? Did they eat breakfast? Do they have 6 tests today? I have to know something about my teenagers before I can predict how they're going to behave. So iron, this number right here, tells us how many valence electrons. We will never be able to figure it out. It will always have to be given to us. So that's going to tell us our charge. So iron, in this case, is going to be plus 3. Oxygen, we already said, is negative 2. Crisscross. So it should be iron 2O3. Now to do that backwards, if I had Fe2O4, I'm going to go backwards. And I know I need, when I write the name of this one, I know it needs the Roman numerals because iron is one of our transition elements. Iron. Anything that's written in there must have it. Some of the others will have it sometimes because anything down in here, and it's the reason they are metalloids, is has to do with those D shells. So iron 2, or iron, so this is a +4, a -2. So iron 4, oh, sorry, iron 4 oxide. So iron 4 oxide. Okay, and the last thing we need to talk about are the polyatomics. A polyatomic means that it is more than one type of atom acting like one ion. So it's greater than one type of atom acting as one. Should be a greater than sign. I'll just erase the parentheses. There we go. Okay, so that's a polyatomic ion. Here is your list of polyatomic ions. Most of them are negative. Few of them are, there's probably only one positive on this one. Ammonium? No. Yeah, ammonium. There are two that show up periodically, but ammonium is the one you probably have to know. Your polyatomic ions, you just have to kind of memorize. I was reading some pluses and minuses to whether to memorize them. The ones you need to know, they will help when we come to predicting and some thermodynamics. But just know, and there's some good YouTube videos on how to memorize and what to memorize. Um, but just understand that they are acting like one. So if I did potassium sulfate, and if they end in ATE or ITE, it is a polyatomic ion. So potassium sulfate, we know potassium, going back to our periodic table, we know that potassium is a K, or well, is a +1. Sulfate, going to my list, sulfate is SO4, and it has a +2 charge. I'm sorry, a -2 charge. So keep in mind, this is acting like one. So some people like to, and this includes me, go ahead and write the parentheses. When you see these uh, when we balance equations, if there's more than one of them, you'll always see them in parentheses. So this -2 will go here. This +1 goes here. So you have K2SO4. So let's try one more. Let's do bromate. Bromate, and let's do magnesium bromate. So magnesium has a +2 charge. And bromate, we said bromate, there it is, BrO3 with a -1, BrO3 has a -1 charge. Putting the parentheses there in the box when I write the box helps me make sure that I put this 2 on the outside here and this 1 here. So MgBrO3 2. Remember, this 2 is telling me I have 2 of the bromate ions. So let me try one more. Let's do magnesium hydroxide. So magnesium hydroxide. Magnesium is still a +2 charge. Hydroxide is a -1 charge. It is right here. OH with a -1 charge. So this will go here. This will go here. So magnesium OH2. And keep in mind that's very different than MgOH2. That is incorrect. This tells me I have 2 OHs. This just tells me I have 2 H's. So keep those parentheses in place when possible. That should cover the basics of ionic compound review. We'll do a little bit more next time. Let me know if you have any questions and have a good day.